What's up, guys? So, a lot of you have been asking for a review of sorts for the upcoming test, and I guess a little bit for the final too, because of course this information will be on the final. So that's what I'm gonna do. So I'm gonna go and I'm gonna take all of the last couple quizzes that pertain to this last test three, and I'm gonna go through every single one of them. Now, you might have different numbers on the questions you did for the quiz. So it's probably not going to match up perfectly with what I have because it changes. It's supposed to change the numbers for everybody. Of course, it cycles, but you should have something really, really similar to what I'm going through. So you should be able to figure out how to solve the problems by how I'm going through them. So that's what I'm going to do. Hopefully, it'll help. Like I said, this next test will go chapter 17 all the way through chapter 21. Type 1, type 2 error, everything in between all that. So we had chapter 17, 18, 19 and 21 and chapter 20, and I threw in some type 1 and type 2 error in that 19 and 21 lecture as well. So all of that will be free game for the test. I'm going to do my absolute best to not make it as hard as what test 2 was. So instead of generating the questions on my own like I had planned to do, I think, don't hold me to it, but I think what I'm going to do is kind of base it a little more on the quizzes and the homework that you've been doing. Obviously, you've had a lot of multiple choice homework. Not exactly going to go that route, but some of the free response stuff, you might look very familiar. I'll put it that way. Not saying all of it is, not saying the majority of it is, but it'll be framed more in the My Math Lab Pearson style way. I'm going to try to use their pre-selected questions, that kind of thing, and at least use their outlines rather than doing it and creating it all on my own, because I feel like in doing that, it made it really, really difficult for some of y'all. So I'm going to try to stick with the same format as what you've been seeing. That's essentially what I'm saying. So anyways, I'm going to start with chapter 17 here real quick. Then we'll do chapter 18, chapter 20, and then the quiz for 19 and 21 as well. So here it goes. Hope it helps. Chapter 17. Obviously, the very first question on chapter 17 was said, on my honor as USC Aiken student, I have completed the work according to the principle of academic integrity. I have neither given nor received any unauthorized aid on this assignment or examination. So, hopefully, y'all didn't cheat. So, obviously, the answer to that one should have been true. Okay, alright. Moving right on along. This question says, in a large class of introductory statistics students, the professor has each person toss a fair coin 12 times and calculate the proportion of his or her tosses that were heads. The student then reports their results, and the professor plots a histogram of these proportions. What shape would you expect the histogram to be? Okay, that's A. I would expect this histogram to be symmetric because the probability of tails and heads, or heads and tails, is equal. Okay, B says, where do you expect the histogram to be centered? It should be centered at 0.5, right? Because the percent chance that this happens is 50%. Okay. How much variability would you expect among these proportions? Okay. Now, if you remember from your lecture notes for this, if you got proportions, it's approximately normal. Your standard deviation is going to be the square root of PQ all over N. Okay. So if I do second square root, P here is 0.5, Q is 0.5. N here is 12, so I should get 0.144 because we're rounding 3 decimal places. So I pull it back up here, we're going to go 0.144. Okay. D says, explain why a normal model should not be used here. Okay. So the success failure condition is violated since each student only flips the coin 12 times. It is not possible to obtain at least 10 heads and at least 10 tails. That would probably be it right there. So let's check them all, be sure. And sure enough, it's all correct. So that was that one. Number 3 says, suppose 30% of the people in your town talk on their cell phones and drive at the same time. If you stood at a busy street corner and watched 50 people drive by, what is the standard deviation of the model you would use for the sample proportion you observe? Okay, so 30% of the people. That means our P is 0.3. So come over here to our calculator. My P is 0.3. second square root 0.3. My Q then would be 0.7. And we watched 50 people. Alright, therefore our standard deviation is 0.0648. Okay, I believe it asked for, let's see, 0.065. Okay, it rounded. So the answer should have been A. If we check it, there it is. That simple for that one. Fourth one here says a college's data about the income freshmen indicates that the mean of their high school GPAs was 3.4 with a standard deviation of 0.25. The distribution was roughly mound-shaped and only slightly skewed. The students are randomly assigned to freshman writing seminars in groups of 25. What might the mean GPA of one of the group seminars be? Describe the appropriate sampling distribution model, including shape, center, and spread, with attention to assumptions and conditions. Make a sketch using the 68, 95, 99.7 rule. Okay, so here we sampled 25, so it's a little small, but not totally small. It was mound shaped and only slightly skewed, so I believe it's normal. Okay, our mean here is 3.4. Easy enough, mean doesn't change. Our standard deviation, that's what you really have to worry about here. Now the standard deviation here is 0.25, but that's not exactly what we're worried about. Remember, we have a group of 25. So what we're really looking at here, if you look back at your old notes and I scroll on up here to the one with the mean on it, you really, and I'll make this a little larger so you can see it a little bit better. If it's going to be normally distributed here, our standard deviation is going to be the original standard deviation over the square root of n. So that's what we need to put there second. So our original standard deviation was 0.25. Our n is 25. So if I come over here to my calculator, so 0.25 divided by, sorry, I think I just typed that wrong. 0.25 divided by square root of n. So the n here was 25. Type that in, we get 0.05. So 0.05. There it is. Okay. Now the next part says what assumptions and conditions must be satisfied for the sampling distribution model to be appropriate. Select all that apply. They don't have to be normal, but they do need to be unimodal and symmetric. They need to represent 10% of the populations, and they also need to be independent. So everything except that first one. Now we're going to make a sketch. Okay, remember the middle has to be 3.4, and then we're going to go out by 0.05. So if you look at that, B is the one that does that on this particular one. So we want to go through and check. We got them all right. Easy as pie. This one on here says the national freshman to sophomore retention rate has held steady at 74%. A certain college has 494 of the 595 freshmen return as sophomores. Does this college have the right to brag that it has an unusually high retention rate? Let's see. So, alright, so we have a national freshman to sophomore retention rate that held steady at 74%. Let's go ahead and just look at this percent. Let's change 494 over 595. 494 divided by 595. 494 divided by 595. That's going to give you a percent of 83%. Seems large, right? But what you really need to do here, right, you need to create you a confidence interval. Okay? So we know how to do this on the calculator. We're looking at 74%. So I can go stat. I can do stat test. Okay? We have sampled a lot of them. So say 1 proportion Z interval, which is actually down here on A. So if we look at a 1 proportion Z interval, our X here, if we're looking at it, oops, wrong screen. Our X here that we can look at is 494. N is 595. Okay. So, does it say a confidence level on this one? I cannot remember. Let's see. Can it brag? I don't know. Let's do 95% confidence just to see what that does. Or if we want to be really special, we can do 99% confidence. But let's do 95 to start with. Okay. If we calculate a 95% confidence level. What we'll notice is the one that we created off the sample there, right? The lower bound on it is 80%, the upper bound is 86%. If we compare that to the national percent of 74%, it's definitely way above it, right? If you want to be a little more picky about it, because it doesn't give you an actual percent, and you want to say, okay, I'm not sure that's enough, I want to be extra picky, I'm going to say I need to be 99% confident. So 1 proportion Z interval, I want to be 99% confident about this since they didn't give me a percent. I want to make sure I'm right. Okay, if I do a 99% confidence interval, it goes from 0.79 all the way to 0.86. So 79% to almost 87%. And if I compare that to that 74%, it's still way above, right? So what I'm seeing here is that they do get to brag that they have an unusually high retention rate, right? So yes, they get to brag because the retention rate's over is over however many standard deviations of the expected 74. Now, what we're looking at here is, okay, is it more than 3 or more than 5? Okay, so if we think about what we know about our rules here, we know that 68% is 1 standard deviation, 95 is 2, 99.7 is 3, right? So it's hard to differentiate with what we've done so far between 3 and 5 standard deviations above. Okay, but what we can do is we can go and find the standard deviation. Okay, remember? So if I pull this up, the standard deviation of the percent, I'll pull it right down here. Let's see if I can be lucky enough to pull right on it. It's right there, square root of PQ all over N. Okay, so what we need to do is, let's see. So what we need to do is we need to take this in our calculator. So if I go 494 divided by 595, right? That's our P. 1 minus P. 1 minus P is our Q. Okay, so there's our P and our Q. Now if I want to find this, what I'm going to have to do is I'm going to have to take the square root of that and divide it by N. So I'm going to do big square root P times Q, all divided by N here was 595. Okay, so that tells me that my standard deviation I'm looking at is 0.015, right? So if I'm looking at that 494 over that 595, right? And I'm comparing that to 74. So I'm taking this, and I want to see how many times, or how many standard deviations away from 74 I am. So I'm going to subtract that, and I'm going to subtract it again. So that's 1 standard deviation away there. There's 2 standard deviations. There's 3 standard deviations. There's 4 standard deviations. There's 5 standard deviations. There's 6 standard deviations, and I'm finally below that 74 threshold. Okay, so hopefully you caught what I did there. If not, go back and rewatch it. Okay, but it essentially took me 5 iterations. On that 6th iterations, I actually dropped below that 74%. So my answer here for this one would be B. Yes, because the retention rate is over 5 standard deviations above the expected rate of 74. If we check that, we'll see that it's correct. Alright, this question number 6, says the score distribution shown in the table is for all students who took a yearly AP Stats exam. Complete parts A through C. So here you have your score, here you have your percent of students, right? So this one, I didn't go through piece by piece how to do this on the calculator. So for you to get all these parts right, if you did, you definitely got some of your bonus points right. So let me show you how to work through part A. It says find the mean standard deviation of the scores. I'll show you the easy way. So I'm going to pull this over to the right, let the calculator work here. So I'll start from a blank screen. I'm going to type both of these lists into my list on the calculator. So stat edit, and I'm going to be in my list. So I'm going to type 5, 4, 3, 2, 1. Okay. Now, on this side, what I'm going to do, instead of percents, I'm going to write it as a decimal. So I'm going to write 0.121. I'm going to write 0.222, 0.251, 0.179, and 0.227. Alright, so I have it all in. I need to find the mean and standard deviation. I'm going to go stat, calculate, 1 var stat. That's how we find the mean and standard deviation. We've done that before. So list 1 is my first list that I have here that I'm pulling from. The only difference here is your frequency list is probably blank, which it has been most of the semester. If you want to, in this case, to make it really, really easy, all you had to do is hit, okay, second stat, which is your list, hit L2, and put L2 next to frequency list. Okay, hit calculate, and it tells you that the mean that you have here is 2.831. So the mean here, 2.831. Okay, standard deviation here, it says is 1.328, and it wants us to round it to 3 decimal places, so 1.328. Easy peasy. Alright, B says, if we select a random sample of 40 AP students, would you expect their scores to follow a normal model? The answer here would be no. The score distribution will resemble the population with an approximately uniform number of scores 1 to 4 and approximately half the number of 5s. Oops. So your answer there would have been that one. In my case, it was C. C says consider the mean scores of random AP or random samples of 40 AP statistics students. Describe the sampling model for these means, shape, center, and spread. Select the correct choice below and fill in any answer boxes in your choice. Okay, so what we're looking at here is we're looking at the mean scores of 40 AP students. Therefore, if we're looking at the mean scores and we're over 30, sampling model should be approximately normal here, right? So it is normal. So my mean here, if it's normal, my mean is going to be the exact same, 2.831. 2.831. And my standard deviation here, remember for the normal model, right? If it's, these are the percents. I'll go back to the very first part where we went over normal. Oops. I just want to show it to you in your notes. Where's that? Right here. So your standard deviation is going to be your original sigma over the square root of that n. Got to remember that part. So our original sigma here is 1.328. So 1.328 divided by that square root of n here, which is 40. So the standard deviation I now have should be 0.209975. Let's see how many decimal places they want us to round to. It says round to 3. So my new standard deviation here would be, to 3 decimal places, would be 0.21. So 0.21. Okay. If we check it, got it all right. So that was a hard one. So props to you if you got that one right. I'm not gonna put one that hard on the exam coming up, but it's still helpful to know how to do it and to know where you screwed up, I guess. This is question number 7. It says, suppose that the IQs of University A students can be described by a normal model with a mean of 140 and a standard deviation of 8 points. Also, suppose that the IQs of students from University B can be described by a normal model with a mean of 120 and a standard deviation of 11. Now I'm going to go ahead and be honest here. When I added this question, I read part A, and I thought all of them kind of followed suit with the style of part A. Part A you should easily be able to do with the information we've learned this semester. Part B, unless you've taken a pretty in-depth statistics course before, you probably wouldn't be able to answer part B with the stuff we learned this semester. And you might have been able to answer, what is it? You wouldn't have been able to answer D as either. You might have been able to answer C. The biggest thing I'm going to focus on real quick You can see the answers there for them if you wanted them. I'll scroll through kind of slow again. If you wanted to try to get them, there's some pretty good explanations online of these style of questions. And it's a really neat statistical approach to them, but it's not something that you should worry about for the upcoming test. This is not covered really in what we're supposed to do this semester. And I didn't know this question set up this way. My fault for not reading all the answer choices. I thought all of them were pretty straightforward because these questions right here from Pearson are supposed to be pulled directly from the book. And there's nothing I found in chapter 17 that even remotely relates to a question of the style of B and D. So anyway, like I said, I do believe you should be able to solve A and C. So let's look at A. I'm mostly focused on how to find A. If you can find A, I'm pretty happy with you at this point. It says select a student randomly from University A. Find the probability that the student's IQ is at least 130 points. Okay, so at least 130 points from University A. They had a mean of 140 and a standard deviation of 8. Okay, we're only selecting one student. I'm gonna come over here, make it a little larger. I'm gonna go second distribution, normal CDF. Okay. 130 is my lower bound. My upper bound is infinity, so I'm going to use 1E99. My mean is 140. My standard deviation is 8. I believe that's correct. I'm going to double check it. So 140 and 8. If I hit paste and calculate it, I should get 0.894. If I look at this, that's the correct answer, 0.894. Like I said, there's another method that you can use that we don't learn in this class to solve B and D. You should have also been able to solve C. If we look at C real quick, C says select 3 University B students at random. Find the probability that this group's average IQ is less or is at least 130 points. So if we're selecting 3, we're looking at group B. So now we have a mean of 120 and a standard deviation of 11. Okay, still at least 130 points. So if I go back to second distribution, normal CDF. Now my new mean here is 120. Okay, my standard deviation here is where you have to be careful. If I pull this back up, let's see, if I pull this back up, 3 students, original standard deviation is 11. I need to go 11 divided by the square root of 3. If I do that and paste it in, I get 0.05767. If you look at this over here, it is exactly rounded what our answer choice is here. Do not worry about B and D. If you're really curious on how to do that, feel free to come back by my office after the pandemic is over and everybody's back on campus, and we will take about an hour to walk through how to do those. Not that they take an hour, but teaching you how to do those would take a little bit of time. So I'm not going to do that right now. It's not the focus of this. The focus of this is to make sure you know the style of questions that I'm going to ask on the test. So be looking for questions of the style of A and C. If you got B and D right, you got some bonus points, and props to you because they were pretty difficult. 8 says, according to a research survey, 25% of adults are pessimistic about the future of marriage and the family. That is based on a random sample of about 1,700 people from a much larger body of adults. Is it reasonable from the research team, or for the research team, to use a normal model for the sampling distribution of the sample proportion? Why or why not? Okay, so the answer here should be yes. It's okay. The data are from a random sample, meeting the randomization condition. The data have at least 10 successes and 10 failures, meeting the success-failure condition. The population is much larger than the sample, meaning it meets the 10% condition. Okay, biggest thing we need to really check here was these 10% successes and 10% or 10 successes and 10 failures in this 10% condition. What you could do here, you got 25% of adults are pessimistic. If you really wanted to check it, you say, okay, 1,700 times 0.25. That gives you 425 individuals. If you did 1,700 times your Q here, since 0.25 is your P, that means 0.75 would be your Q, and that is also much larger than 10. So you're okay here. That should have been a really easy one. Everybody should have gotten that one right. Question says, it is believed that 4% of children have a gene that may be linked to juvenile diabetes. Researchers at a firm would like to test new monitoring equipment for diabetes. Hoping to have 23 children with the gene for their study, the researchers test 728 newborns for the presence of the gene linked to diabetes. What is the probability they find enough subjects for their study? Okay, this one's pretty simple. I'm going to come over here to the calculator. We're going to go second, distribution, normal CDF, right? So, we want at least 23 of them to have the gene. Fair enough, 23 out of 728. We're looking at a percent here, so we're not going to type 23 in. We're going to type the proportion or the percent in. So I'm going to type 23 out of 728. So I've got 23 out of 728 there. It's going to go up to infinity, so I use 1E99. My mean here is 0.04. My standard deviation that I need to use is second square root of P, which is 0.04, times Q, which is 0.96, divided by 728. Alright, if I do that, paste it in and hit enter, I get 0.876, which is the correct answer. And it's as simple as that. This one says, just before a referendum on a school budget, a local newspaper polls 416 voters to predict whether the budget will pass. Suppose the budget has a support of 53% of the voters. What is the probability that the newspaper's sample will lead it to predict defeat? Okay, so, alright, the budget, right, has support of 53% of the voters. What's the probability the newspaper sample will lead it to predict defeat? If you're going to get defeated, then less than 50% of the people have to vote for you. Does that make sense? Hopefully it does. So pull up my calculator. I'm going to go second, distribution, normal CDF. We're going to go from negative infinity. So if he gets anything less than 50% of the votes, he's going to lose. He's going to be defeated. Alright? So, I'm going to use 0.5. Right? Alright? 50%. Now, our mean here, if we look at it, our mean here was 53%. So, the budget has support of 53% of the voters. So, that's what I'll use for a mean, 0.53. Okay. Now, I have to look at the standard deviation. So, we're looking at second square root, 0.53 times, my Q here would be 1 minus 0.53, which would be 0.47. And then that's going to be divided by my N. My N here is, let's see, 416. Okay, paste that in. And I should get 0.11. And if we look at the answer choice, that is the correct answer choice. It is indeed 0.11. And it's that simple. Alrighty guys, so we finished chapter 17. We're on to chapter 18. Chapter 18 says, the first one I've got here says, direct mail advertisers sent solicitations, aka junk mail, to thousands of potential customers in hope that some will buy the company's product. The response rate is usually quite low. Suppose a company wants to test the response rate to a new flyer and sends it to 1,170 people, randomly selected through their mailing list of over 200,000 people. They get orders from 149 of the recipients. Use this information to complete parts A through D. Alright, let's do it. Create a 95% confidence interval for the percent of people the company contacts who may buy something. Okay. 95% confidence interval. We can do that. Okay. I'm going to pull it up. We're going to go stat, calculate, stat test. Okay. Now, we're going to do 1 proportion Z interval. Okay, there it is. Now let's look at the question a little more clearly. Okay, so they get orders from 149 of the recipients. 149 is going to be your X. They sent it out to 1,170.
We want to be, how confident do we want to be in this one? 95% confident. So 0.95. And we're going to calculate it on out. And it gives it to you right here. The key thing to notice here is it wants you to change it to a percent. And it says to round to 1 decimal place is needed. Okay, so this will be 10.8 to 14.6. 10.8 to 14.6. Very important to see how it wants you to write it. B says explain what this interval means, and you've got several different choices. First one says the values for the interval bounds should be subtracted from 95% to obtain the company's true confidence interval. No. The company is 95% confident that the percentage of people who will respond to the flyer falls within the confidence bounds. The company is 95% confident that the probability a randomly sampled person will respond to the flyer falls within the confidence interval bounds. D says the company is 95% confident that the percentage of people who will not respond to the flyer falls within the confidence bounds. Okay. One that sounds most correct to me is B. The company is 95% confident that the percentage of people who respond to the flyer falls within the confidence bounds. All right. C says explain what 95% confidence means. Okay. A says about 95% of all random samples of size 1,170 will produce intervals that contain the true proportion of people who will respond to the new flyer. B says about 95% of all random samples will produce intervals that contain the true proportion of people who respond to the flyer. C says about 95% of all randomly sampled people will respond to the flyer. That's not right. D says 95% of all random samples of size 1,170 will produce intervals that do not contain the true proportion. That doesn't sound right either. Should be A. About 95% of all random samples of size 1,170 will produce intervals that contain the true proportion of people who will respond to the new flyer. D says the company must decide whether to do mass mailing. The mailing won't be cost effective unless it produces at least a 6% return. What does your confidence interval suggest? Okay, won't be successful unless there's a 6% return. Looks like we're suggesting there'll be between a 10% and a 14% return. So we ought to go ahead and do that mass mailing because it looks like we're going to have more than that 6%. If we check our answers, we get 100% on this first one. Got them all right. On to the next one. So the next one for mine, and yours might have been in a different order because I think I randomly shuffled it for everybody. But the next one says a recent study of 2,800 children randomly selected found 22% of them deficient in vitamin D. It wants us to construct a 98% confidence interval for the true proportion of children who are deficient in vitamin D. This one's really easy. This is part A. We're just going to pull up the calculator. We're going to do stat test 1 proportion Z interval. Alright. Our X in this case, if we look at it, our X here, okay, doesn't give us an X right off the bat, but it does tell us that 2,800 children were randomly selected and 22% were deficient. So 2,800 and 22% are really what we're looking at here. So 2,800 is your N. Remember to find your X, you just got to multiply your percent. 22% times 2,800. Make sure it comes out a whole number. If not, adjust accordingly. Alright, we want to be 98% confident. 0.98. Calculate it out. Hit enter. And it gives us our interval. So from 0.20179 to 0.23821. And if we compare to what we have here, when we round it appropriately, it is indeed correct. Okay, you look and glance, but it is indeed correct. Okay, B says, explain carefully what the interval means. The correct one is that we are 98% confident that the interval contains the true proportion of children deficient in vitamin D. C says, explain what 98% confidence means. It means that about 98% of random samples of size 2,800 will produce confidence intervals that contain the true proportion of children that are deficient in vitamin D. That's what you should have gotten for the second one. The third one, a reproductive clinic reported 41 live births to 210 women under the age of 40 who had previously been unable to conceive. Complete parts A through D below. Okay. A says find a 90% confidence interval for the success rate at this clinic. Alright. So we can look at these tables. Okay. If you need them, they have the Z tables there for you. We've been using the calculator. So you really shouldn't have needed these, but if they were there for you, if you had taken AP Stat or something in high school, really like to use those. You could have used them if you wanted to. But here what we're going to do is find a 90% confidence interval for the success rate at this clinic. We have all the information we need. Okay. So 41 births, 210 women. We want to be 90% confident. That's all we really need to know. We're going to go stat. We're going to go test. We're going to scroll down to 1 proportion Z interval. Okay. Our X here, what we're going to use for X is that 41. 210 is what we're going to use for N. Our confidence level here is going to be 90%, so just 0.9. Then we're going to calculate. Calculate, it gives us from 0.15 to 0.24, depending on how we round and how we were asked to round. It was indeed what we have here. Okay, easy peasy for part A. Interpret your interval in this context. Choose the correct answer below. The correct answer there was that there is 90% confidence that the interval contains the true proportion of women under 40 who were helped by the clinic and gave birth. Simple enough. Explain what 90% confidence means. If we repeated random samples of the sample size were selected, it is expected that about 90% of the confidence intervals would contain the true proportion of women who had previously been unable to conceive who were helped by this clinic. Do the data refute the clinic's claim of a 25% success rate? Explain. So here, alright, before we answer that, our confidence interval here says that the success rate is somewhere between 15% and 24%. So it is actually lower than that 25% success rate. So it does indeed, yes, refute the claim of 25% success. Okay, yes, because the value of 25% is not within the confidence interval. That's how you should have answered that one. Question says of 560 broiler chickens purchased from various kinds of food stores in different regions of the country and tested for types of bacteria that cause foodborne illnesses, 63% were infected with a particular bacterium. Construct a 95% confidence interval. Alright, so 560, 63%. That's really all we need in a 95% confidence interval. We're going to go stat. And we're going to go over here to test. We're going to do a 1 proportion Z interval. Okay, so if we look at the problem again, we don't know what our X is here, but we do know our N is 560. And we know that it affects 63%. So 0.63 times 560 should give you that X. Okay, it is not a whole number here, so we have to round to 353. Okay, we want to be, in this particular question, we want to be 95% confident. So we're going to be 0.95. Alright, oops, yep, good to go. And hit calculate, and it has constructed our interval for us. So 0.59 to 0.67. So if I come here, 59% to 67%. Pretty easy. Okay. B says, what does the confidence interval say about chickens sold in the country? The correct answer would be, we are 95% confident that the interval captures the true proportion of all broiler chickens sold in the country that are infected with the bacterium. Okay, so that's kind of scary, right? Between 59% and 67% of all chickens sold in the country basically contain the bacteria that could make you sick. Is the government's spokesperson's criticism valid? So here, C says, a government spokesperson claimed that the sample size was too small, relative to billions of chickens slaughtered each year, to generalize. Is this criticism valid? No. Okay. As long as the necessary assumptions and conditions were met, the results can be generalized. Okay. So, this is a very important part of the statistics class because you got to kind of have a mind of your own. right? And if you know the information behind how these studies and surveys and all this information is done, you can kind of refute people's claims, right? So here you've got somebody from the government trying to say, oh, well, your sample size is too small, there's millions and millions of chickens and this, that, and the other, you could have gotten this, that, and the other. But you know, because you've taken this class and you know how to generalize this material, you know that his claims are wrong and you are correct. So good to go. This question says a student is considering publishing a new magazine aimed directly at owners of Japanese automobiles. He wants to estimate the fraction of cars in the United States that are made in Japan. A computer output to the right summarizes the results of a random sample of 50 autos. Explain carefully what it tells you. Okay, so they took a z-interval for proportion with 95% confidence and found that essentially between 32.7 or 32.8% and 50.8% of cars are going to be this Japanese, right? So the correct answer here is we are 95% confident that 32.8 and 50.8% of cars in the United States are made in Japan. That one's pretty easy and straightforward. That's literally the answer to that one. The sixth question here says a philanthropic organization sent free mailing labels and greeting cards to a random sample of 100,000 potential donors on their mailing list and received 4,934 donations. Give a 95% confidence interval for the true proportion of those from their entire mailing list who may donate. B also says a staff member thinks that the true rate is 5%. Given the confidence interval you found, do you find that rate plausible? So let's look at it though. Okay, we need to find that 95% confidence interval. I'm going to pull up our calculator. I'm going to go stat. Test. Okay, we're going to scroll down to one proportion z interval. We need our x, our n, and our confidence level. Here, confidence level is 95%. That stays the same. Our x here is 4,934. 4,934 out of 100,000, I believe. 100,000. Okay, and if we look at it, double check, make sure I got all the numbers in right. Alright, we're going to go down, hit calculate. And if we hit calculate, our interval is from 0.048 to 0.05068. Okay, tells you to round appropriately. And you see that indeed we have it here. So 4.8% to 5.07%. That indeed matches what we have here. Remember, you got to change it to percent if it asks you to change it to a percent. Okay. Now, given that confidence interval that we just found is the proposed rate of 5% plausible, yes, indeed, it's plausible. It falls within the confidence interval, therefore it's plausible. So, that's it. On to the next one. Insurance company checks police records on 591 accidents selected at random and notes that teenagers, y'all pesky little teenagers, were at the wheel in 81 of them. Alright, it happens. Everybody gets an accident. It's happened to me before. A says construct the 95% confidence interval for the percentage of all auto accidents that involve teenage drivers. Okay, that's easy enough. 95% confidence interval. We know how many. Our 81 is our X, 591 is our N. So, if we come through here, we're going to go stat, scroll over to test, scroll down and do our confidence interval. So, like I said here, I'll pull it up once more. Alright, our X is 81, and our N is 591. And I've got another email, how about that? Alright. 95% confidence interval here, and it goes from 10.933% to 16.478%, which is exactly what we have here rounded correctly. Alright, B says explain what your interval means. We are 95% confident that the true percentage of accidents involving teenagers falls inside the confidence interval limits. C says explain what 95% confidence means. About 95% of random samples of size 591 will produce confidence intervals that contain the true proportion of accidents involving teenagers. A politician urging tighter restrictions on driver's licenses issued to teens, says 1 in every 5 auto accidents a teenager is behind the wheel. Does the confidence interval support or contradict this statement? Okay. We're somewhere between almost 11% and 16.5%, right? So, oh, excuse me, I apologize for that, guys. 1 divided by 5 is 20%, right? If I come back here, he's saying that around 20% of the accidents are caused by teenagers. Our confidence interval has determined that that is a lie. So, confidence interval contradicts the assertion of the politician. The figure quoted by the politician is outside of the interval. That would be the correct answer for that one. Was pretty much a gimme. It says if the level of confidence increases, the confidence interval gets wider. Simple enough. On to the next one. This one says a consumer advocacy group published a study of labeling of seafood sold in 3 U.S. states. The study found that 14 of the 28 red snapper packages tested were a different kind of fish. This actually happens a lot. I've watched like a few History and Discovery Channel shows about this, even a few YouTube videos as well. This happens a lot. Fish are grossly mislabeled, especially when they come from overseas. So people get ripped off all the time on this. But anyway, back to the question. Assume that the study used is a simple random sample. Complete parts A through C below. Alright, so let's do that. A says, are the conditions for creating a confidence interval satisfied? Explain. The correct answer should have been yes, because the sample is a simple random sample. The sample is less than 10% of the population, and there are at least 10 expected successes and 10 expected failures. Alright, so 14 out of the 28 red snapper packages were a different kind of fish, and that means that 14 out of 28 had to be the right kind of fish too, right? Because 14 plus 14 is 28. 14's bigger than 10, right? Obviously, there's a lot of fish coming in the country, so the sample is going to be a whole lot less than 28% of the whole population of fish coming in the country. And it was a simple random sample, so you're good to go. That kind of works its way through A. B says construct a 95% confidence interval for the proportion of red snapper packages that were a different kind of fish. Okay, got a calculator here. Gotta pull it up, clear it out, stat, test, 1 proportion, Z interval. Okay, we can do this. Alright, bring it back up. Let's see what we're working with here. 14 out of 28. So, X is 14, N is 28. Alright. What percent confidence were we working with here? Was it 95? It is indeed 95. Okay. Leave that there. Hit calculate. We get somewhere between 31 and 68%, which should be exactly what I have here. Yep. 31.315 to 0.685. There it is. C says explain what the confidence interval from part B says about red snapper sold in these 3 states. Select the correct choice below and fill in the answer boxes with your choice. So the correct answer for that one should have been 1 is 95% confident that between 31.5%, you had to fill that part in, and 68.5% of all red snapper sold in food stores and restaurants in these 3 states is not actually red snapper. That would be the correct answer choice for there. And that completes chapter 18 quiz. On to the next quiz. So this is chapter 20 quiz here. These are in random order, so yours might be in a different order, so you have to search for the questions in yours, and like I said, the numbers could be a little different. But here we go. First one says, a company tested 11 random brands of vanilla yogurt and found the number of calories per serving given below. Note that more than 110 different brands of vanilla yogurt exist. How about that? Okay, so check the assumptions and conditions for inference. Is the independence assumption met? Yes, indeed. It is met. Is the randomization condition met, or is the sample suitably representative? Yes, indeed. Is the 10% condition met? We can check this one. Okay, more than 110, right? So, second quit, 11 divided by 110. That is, hey, that's 10%. We're good to go, right? More than 110. right? 11 out of 110 is 10%. There's more than 110, so we're good. That means we're going to be less than 10%. All right, is a nearly normal condition met? Indeed it is. B says find a 95% confidence interval for the average calorie content of vanilla yogurt per serving. Okay, let's get into the nitty gritty here. All right, we've got this data list here. So what we're going to want to do is we're going to want to pull up our calculator. We're going to go stat, edit, type that there list in. Okay, so we got the list in. I've typed mine in. If you need more time to type yours in, you can type yours in that you have on your example, or you can follow my example if you want to get exact numbers, right? So what we're going to do, find a 95% confidence interval. What I have to note here, right? I've got all this information. I do not have a population standard deviation, and I have a really small sample size of less than 30. So what I'm going to do, I'm going to do stat, and I'm going to do test, and I'm going to do a t interval. Okay. Now, I don't have the stats. I have the data. I've typed it in my list. So I'm going to highlight data, list 1, frequency needs to stay 1. Let's make sure that we want to be 95% confident. I think we do in this particular example. We do. So that pretty much stays the same as well. The hardest part there was typing your list in. You hit enter, and it gives you the interval from 111.57 to 150.25. All right, so if we pull this up, it's exactly what it has there. All right, so that's the correct answer for that one. Let your calculator do all the work. C says interpret this interval for somebody looking to buy a yogurt. Choose the correct answer below. We can be 95% confident that the interval contains the true average calorie content per serving of yogurt. That's what we're looking for. That's the correct one. All right, that's simple. 6 more to go. Question says livestock are given a special feed supplement to see if it will promote weight gain. Researchers report that 77 cows studied gain an average of 56 pounds and that a 95% confidence interval for the mean weight gain the supplement produces has a margin of error of plus or minus 11 pounds. Some students wrote the following conclusions. Did anyone interpret the interval correctly? Explain any misinterpretations. Complete parts A through E below. Okay, the first one said that 95% of cows studied gained between 45 and 67 pounds. However, this interpretation is incorrect. The confidence interval is actually for the population mean and not for individual cows in the study. So we're not talking about individual cows here. We're talking about a mean of all cows, if that makes sense. So that's where that interpretation went wrong. B says one is 95% sure that a cow fed this supplement will gain between 45 and 67 pounds. That interpretation is also incorrect. The confidence interval is not for individual cows. It's for a group of cows, right? So that's where they kind of messed up on that one. Okay. C says one is 95% sure that the average weight gain among cows in this study was between 45 and 67 pounds. That interpretation is also incorrect. We actually know the average weight gain in the study was 56 pounds, so there's no need to generalize. So we only generalize when we're going to other studies. D says the average weight gain of cows fed this supplement will be between 45 and 67 pounds 95% of the time. And guess what? That one's wrong too. This interpretation is incorrect. The average weight gain of all cows do not vary as a constant value which the confidence interval estimates. Okay, so we've got one more here. It says if this supplement is tested on another sample of cows, there's a 95% chance that their average weight gain will be between 45 and 67 pounds. That one's also incorrect. There's a 95% chance that another sample will have its average weight gain within 2 standard deviations of the true mean. And there it is. Nobody interpreted it correct in this particular example. So on to the next one. This example says students investigating the packaging of potato chips purchased 6 bags of chips marked with a net weight of 29.4 grams. They carefully weighed the contents of each bag, recording the following weights. And it gives you the list there. Okay. Does the data satisfy the assumptions for inference? Is the randomization condition satisfied? No, the 6 bags were not selected at random, but it probably is reasonable to think that these bags are representative of all bags of chips, right? So they didn't go out and randomly select them. But it's not like they somehow manipulated the system to get certain bags of chips. Therefore, the chips probably are pretty representative of all chips out there. Is the 10% condition satisfied? Yes, 6 bags of chips definitely less than 10% of all bags of chips out there. Is the nearly normal condition satisfied? Yes, the sample of 6 bags of chips is approximately normal. Okay. So B says find the mean and standard deviation of observed weights. So we have our weights here. All I did over here on the calculator is I typed them into my list 1. Remember, stat, edit. There's your list 1, right? So if you wanted to find just the mean and standard deviation, you could do second count, 1 variable statistics, frequency list. Just clear that out. Only thing you need is list 1 and hit calculate. It tells you your mean is 28.8 and your standard deviation, it gives you that as well, and it matches exactly what you have here. 28.8 for your mean, standard deviation right here. S of x, sample standard deviation 0.357777, whatever. We rounded 2 decimal places, 0.36. Alright, now we need to create a 95% confidence interval for the mean weight of such bags of chips. Okay, oops, sorry for shaking the camera. Alright, so what we're going to do here, we've got it typed in. I'm going to go stat test, and I'm going to do the t interval here. I'm going to pull in the data, right? I'm going to double check. I'm pretty sure we want to be 95% confident, but let's make sure. Indeed, it says 95% confidence. So I calculate it, and it gives it to us, 28.425 to 29.175. And for us to round appropriately, it goes to 28.4 and to 29.2. Easy enough. So calculator does that all for you. D says explain in context what your interval means. So the correct choice here is we are 95% confident that the interval contains the true mean of weight, or the true mean weight of the contents of a bag of chips. Okay. E says compliment or comment on the company's stated net weight of 29.4 grams. Okay. So before we even look at the answer choices, they said it's supposed to be a net weight of 29.4 grams. 29.4 grams doesn't fall in our confidence interval, right? Therefore, we believe that they're wrong. So since the interval is below the stated weight of 29.4 grams, there's sufficient evidence to suggest that the company is filling the bags to less than the stated weight on average. And there you go. That is the answer to the third one here. Question number 4 says a scientist measured the speed of light. His values are in kilometers per second and have 299,000 subtracted from them. Okay. I had a few people email me about this one. That's typically where they messed up, is they didn't calculate in this little piece right there. Here reported the results of 30 trials with a mean of 756.24 and a standard deviation of 107.97. A says find a 95% confidence interval for the true speed of light from those statistics. Okay, so 30 trials, mean of this, standard deviation of that, but still no indication of whether or of what the population standard deviation is. So we have our sample standard deviation, therefore we're using a t-test. How about that? We're going to go stat test t-interval. Alright, we actually have the stats to type in here, so we need to highlight that. So our sample average here, look at it, sample average is 756.24, 756.24. Our sample standard deviation here, sample standard deviation 107.97, 107.97. Okay, how many things did he sample? He sampled 30. Yeah, 30 trials. So N is 30. Confidence level. How confident did the man want to be? Want to be 95% confident. So we have it all in there. We have to calculate it. And we get 715.92 to 796.56. But that is not the answer. We have to add that 299,000 to each. Okay, and you notice if we do that, we get 299,715.92, 715.92, right, that makes sense. And we get 299,796.56, 796.56, makes sense, right? So that one's a little picky there, so you had to be careful of how exactly it wanted you to manipulate your units. B says, in words, what does 95% confidence interval mean? means with 95% confidence based on the data the speed of light is between the lower and upper bounds of the confidence interval, which is stated above. The next one says, what assumptions what you make in order to use your method? Select all that apply. The measurements have to be independent, right? The data comes from a distribution that is nearly normal, right? Doesn't need it to be uniform, actually need it to be nearly normal. So B, exclude that one. That's why it wasn't selected. D says the measurements arise from a random sample or suitably randomized experiment. Okay, so that one was selected as well. E was not selected. E said the sample is drawn from a large population. Okay, it's not necessarily needed in this case. Okay, and that finishes off question number 4. This one says an English professor is attempting to estimate the mean number of novels that the student body reads during their time in college. He is conducting an exit survey with seniors. He hopes to have a margin of error of 5 books with a 99% confidence. From reading previous studies, he expects a large standard deviation. Is going to assume it is 8. How many students should he survey? I'm going to actually take this to the board, and I'm going to show you how to solve it. So, formula for this one was at the very bottom of your chapter 20 notes. Is z squared times sigma squared over me squared. Okay, the z-score that corresponds to 99% confidence is 2.576. Square that. Our sigma here, we decided to let it be 8. That's what the problem said. So we square the 8. And then our margin of error here was 5. We square it. If you type all this in your calculator, you get 17. And that should be your answer. And I apologize because my dogs are probably going to be snoring the rest of this video because they're tired. If you can see them down there, they are trying to hang out and hang their way through math, but they're a little bored with it too. So, on to the next one. 6 says a consumer advocate wants to collect a sample of jelly jars and measure the actual weight of the product in the container. He needs to collect enough data to construct a confidence interval with a margin of error of no more than 4 grams with a 95% confidence. The standard deviation of these jars is usually 3 grams. Let's estimate the minimum sample size required. Okay, we'll take this one to the board as well, and we'll do it in that same manner. So, same formula. The Z star, or the Z that corresponds to 95% confident, is 1.96. I'll square that. My standard deviation here was 3. I'll square that. My margin of error is 4. I'll square that. I'll type that in the calculator. I get 2.1609. Now the key here for this one is it says round up to the nearest whole number. So it says specifically round up. So I round up to 3, and that's the answer that I get there. The last question of the Chapter 20 quiz says the housing market has recovered slowly from the economic crisis of 2008. Recently, in one large community, realtors randomly sampled 42 bids from potential buyers to estimate the average loss in home value. The sample showed the average loss was $9,733 with a standard deviation of $339. Complete parts A through C below. And Sam, really? Hey, stop snoring. Okay. A says, what assumptions and conditions must be met or checked before finding a confidence interval? How would one check them? So the correct answer for that one is the data are assumed to be independent from a normal population. We've got to check the independence assumption with the randomization condition, and we've got to check the normal population assumption with the nearly normal condition using a histogram. Okay. B says find a 90% confidence interval for the mean loss in value per home. Okay, we can do this. All right, 42 bids, right? Sample showed 9,733, standard deviation of 1,339, but it doesn't give us the population standard deviation, so guess what? We're still going to use a t-test. We're going to come over here, we're going to do stat test. Okay, we want to do t-interval. Okay, pulling the stats here. Good Lord, them dogs can snore. I don't know if y'all can hear that, but they are sawing some Z's. Alright, so here, our mean here is 9,733. Okay, our standard deviation is 1,339. Okay, how many did they sample? They sampled 42. Our confidence level here, we want it to be 90%. So we need to change it from 95 to 0.90, or just 0.9 is fine. Okay, that gives us our confidence interval here from 9,385.3 to 10,081. So if you look at it, that's exactly what it has right there. C says, interpret this interval and explain what the 90% confidence means in this context. Choose the correct answer below. The correct one to choose is 1 is 90% confident that the true average loss in home value is between the lower boundary of the interval and the upper boundary of the interval, which is stated above. So that completes chapter 20. On to the next quiz. So you still have access, obviously, and the ability to take the chapter 19 and 21 quiz. Therefore, I'm not going to do the whole 19 and 21 quiz. If you have specific questions about the 19 and 21 quiz, please do not hesitate to email me, and I will try to help you with those specific questions. I will do one. That's the best I can do for you. Okay? But like I said, if you have specific questions, I will help you with specific questions. Email me all day, all night long, and get back to you as quick as I can. But I'm not going to go through the entire quiz. I'm nice, but I ain't that nice. I ain't going to go through the entire quiz here just for you to go through and get it that easy. Okay? But I'll show you one. How about that? So this one says the housing market has recovered slowly from the economic crisis of 2008. Recently, in one large community, realtors randomly sampled 34 bids from potential buyers to estimate the average loss in home value. Samples showed the average loss was $8,867 with a standard deviation of $1,922. In 2011, the average home in this region of the country lost $8,508 in value. Was the community study by realtors unusual? Use a t-test to decide if the average loss observed was significantly different from the regional average, with a 0.5 as the p-value cutoff level. So essentially your alpha level here is 0.05. Okay, this is really similar to what we kind of did with the confidence intervals. Okay, first thing we got to do is state the hypothesis. So your null hypothesis is that it's going to be the same as it was in 2011. Okay, in 2011 the mean was 8,508. So your null hypothesis is that the mean is 8,508. Your alternative hypothesis is that it's somehow different, so it's not equal to. Easy enough. Calculate the test statistic. Now I told you in the email, if you read your emails, that you can find this by simply calculating this on your calculator in the normal manner. What I mean by that, we're doing a t-test. Stat. Okay, test. T-test. Okay, we're going to input these statistics here. Our mean here for this one, we said was 8,508. 8,508. There she is. Our sample mean showed the average loss was 8,867. 8,867. There she is. Sample standard deviation that we found here. Sample standard deviation was 1,922. 1,922. Alright. How many did we sample here? Right in here was 34. Okay. So 34 will go here. We determined it to be not equal. That's what our null hypothesis related this to. All we got to do now is calculate. I told you it would give you your t-value right there. 1.089132014. And it wants you to round appropriately here. So that's exactly what they have there. They rounded to 2 decimal places, 1.09. So you don't have to go calculate that by hand. I'm telling you, your calculator does it for you. If you read your email, you got all that right. Now it also asks for the p-value. Your p-value here is 0.284, which you can see is just this rounded. Easy enough, right? Not hard. Now we need to state the conclusion. So here, we should fail to reject the null hypothesis and conclude the loss of home values in the community does not appear to be unusual. Why? Because our p is greater than our alpha. Our alpha here is 0.05. Our p is 0.284. Our p is greater than our alpha. Therefore, we fail to reject the null hypothesis, which is exactly what we stated and concluded here. Now, you got 7 other questions. A lot of them are really similar to this. You go through it in the same manner. If you can do this one, you should be able to do the rest of them. You do have one on there about type 1 and type 2 test. You need to review that. Go back to the lecture and review how I went through that, or Google type 1, type 2 error. It's fairly straightforward. Okay, if you have any questions, please don't hesitate to email me. Like I said, I'm not going to go through this entire quiz, but I did give you one. Hopefully it helps. If you're really stuck on it and you really need extra help, email me, reach out to me. I'll do the best I can to help you. All right. Other than that, I'll have the test up shortly, and good luck with it. If you have any questions with it, let me know. I will have some other stuff uploaded. Let me change so I can talk to you straight face to face. So, like I said, straight face to face. Here we are. So, hopefully that review was helpful. First off, because it took me a long time to do. Been dealing with little dogs here. Hopefully they didn't snore too loudly throughout it. If you need help with anything, or if something didn't make sense to you, send me an email. We can try to work through it. Okay. I want you to be prepared for test 3 and for the final exam if you have to take it. Remember, in this class, I've got it set up to where if you make a B or better, you don't have to take the final exam. Doesn't mean you don't. If you have a B and you want an A, I'm not holding you from taking the final exam. Go on ahead and take it. It's not going to hurt you. Okay. So I'll basically have the final exam set up just like I do now. With the other 2 exams we're having to do, test 2 and test 3. All right. So if you want to go in there, I'm going to have it available to everybody. Right. I'm not going to pick and choose who can take it and who can't. I'm going to have it available to everybody. So if you have a B and you want to try to get an A, go in there and try it. If you mess it up, I'm not going to hold it against you. Okay. That being said, everybody else, if you have below a B, get as best you can on it. Okay. It's meant to up your grade. It's not meant to lower your grade. It is going to be difficult, but as you know, with everything else, I throw as many bonus points in there as I'm allowed to. If you have any questions, email me. Please don't hesitate to reach out if you're behind for some reason. I know there's been a lot going on with a lot of different people. Let me know. I'll try my best to accommodate as best I can within my means. If it was something before the break come out, there's not much I can help you with, right? We were in school. But if it's something with after this whole COVID-19 thing come out and you hadn't contacted me about it, please get to me quick because semester's almost over. We got less than a week left. So you really need to jump on it. But other than that, hopefully the review was helpful. Hopefully, you know, even though this was a kind of rough, kind of weird semester for everybody, hopefully you made it through and you learned something that you can carry forward and either use in whatever you decide to do with your life, or maybe you really like stats and you want to go on pursue it further. That's cool too. If you need me, I'll be here for you as best I can. I really don't know what else to say, but good luck. If you need anything, like I said, I'm here. Appreciate y'all sticking with me.